Hello and good morning. So today I want to present assignment 2, subject hydraulic. Our lecturer is Madam Tan Sioning. Our group is Muhammad Afiq bin Muhammad Mardan and me, Muhammad Faruqi bin Yaras. So this is our content for question 1, meaning equation, curricular channel. Question 2, base hydraulic section. And question 3, specific energy and solicit gate. And question 4, hydraulic jump downstream depth. Introduction, uniform flow. Flow rate, velocity, depth flow, cross-sectional area of the flow, and slope of the base channel is the same between a section with other section. Open channel, a channel that is exposed to the atmosphere and not fully met by the solid boundary. So we are going to the question 1. Question 1, meaning question, curricular channel. So we need to determine the bed slope required to maintain this discharge under uniform flow conditions. So diameter given is 1.2 meter. For half full flow depth, we need to divide by 2, so we get 0.6 meter. Discharge given is 1.8 meter cubic per second. Meaning synchronous conversion N given is 0.013. So we need to find flow area for half full circular pipe A by d power of 2 divided by 8. So we get 0.5655 meter power of 2. So second, we need to find weighted perimeter and hydraulic radius. So this is our weighted perimeter, and then we get 1.8850. So R, we need to find R, so we get 0.3. R is equal to area over perimeter, weighted perimeter. So next we're going to meaning equation Q. Q is equal to 1 divided by N darab A darab by R 2 power of 2 per 3 by 1 per 2 by 3 power of 1 per 2, and then we get S, and then we get bed slope S is equal to 0.0085526. So flow velocity and flow type. Average velocity V equal to Q per A. So we get 3.183 meter per second, and hydraulic depth DH is equal to A divided by T. So we get 0.471 meter. For float number, this is the formula for a float number, and then we get 1.480.
So hello, my name is Muhammad Afiq Mardan. My matrix number is 0723F1001. So I will explain the question 2 and question 4. For the question 2, the data we have, the N is 0.012, Q is 10 meter cube over second, B is 5 meter, SO is 0.0005, Z we don't know, so we must to find Z. Z is we can answer 0.67. So in the first is we must to find using the Q formula, is which is the Q is equal A 1 over N times R power of 2 over 3 times SO power of 1 over 2. So after that we must find the area which is b open bracket b plus zy close bracket times y. So we get the a is 5y plus 0.67 y square, and then we find p for the SO, for the R. So P is the P formula is P equal B plus 2y punca kuasa 1 plus Z square. So we get answer the P is 5 plus 2.4074y, and then we get the R is A over P, the formula. So we get y R is the answer lah. And then after we get this, we using the Q formula back and put the data we have until we get the answer is 5.3570 equal open bracket 5y plus 0.67y square close bracket open bracket 5y plus 0.67y square over 5 plus 2.4074y close bracket power of 2 over 3, and then we get this answer. We must do using the formula try and error, and which is the Q we get is 5.3570, and then we must calculate until we get the similar or the same. So which is we have the final answer is for the y is 1.07645. Okay, so this is for the question A question lah. For the B question, firstly we must do using the formula B plus 2zy equal to y punca kuasa 1 plus z square. So after we calculate, put the data we have in the formula, we get the y is 4.6816.
So we're going to question 3. A, we need to find specific energy. E equal to y plus v power of 2 divided by 2g. So we get specific energy is equal to 5.7998 meter. So for critical depth is yc. So we need to find Q at first. So we get Q is 11.4 meter cubic per second, and then we need to find YC. The formula is Q power of 2 divided by G power of 1 per 3, and then we get 2.3662 meter. And then we are going to indicate location of flow is subcritical or supercritical. So we need to use FR formula first, fault number formula. So fault number formula is V divided by punca kuasa GYC, and then GYZ, and then we get 2.789, more than 1. So fault number is more than 1, so it's supercritical. And then for E, critical velocity. So VC is equal to punca kuasa GYC, and then we get 4.8779 for critical velocity.
Okay, so for the question 4, which is the data give the weight is 3.3 meter, Q is 3.6 meter cube over second, the S is 0.0005, the N is 0.025. So we use the formula Q back. Yes, Q is A1 over N times R to power of 2 over 3 times SO power of 1 over 2. So area we get, we know area we have is Y times 3. Weight per meter we get is 2Y plus 3. And the R we get is 3Y plus 2Y plus 3. 3Y time 3Y over 2Y plus 3. So using the formula Q back, and then use the data given and data we have, and then we get the final answer is 2.0870 equal Y times open bracket 3Y over 2Y plus 2 close bracket power of 2 over 3. So we get the Q 2.870. So we must find the near or the same, which is like same like the question 2 what we do. Yeah. So after calculate, we get the answer Y is 2.071 is for the Q 2.0870. Okay, so after that we find to YC. The formula is punca kuasa 3 Q square over 9.81. So we get answer for the YC is 0.7082 meter. Okay, after that we must to compare the Y we get and YC to determine Y we get is Y1 or Y2. So after we compare, Y we get is bigger, so that is a Y2. So we must to find Y1. But in the Y1 formula have the V formula is have the B, but we don't have the B, right? So we using the Q equal AB, the formula for the Q to find the V. So we get the V is 0.9013 meter per second. After that we use the formula Y1 to find the Y1, input the data, so we get the Y1 is 0.1541 meter. After that we must to determine the what type of flow, right? So we Y1 over compared to YC, so we get the Y1 is below than YC, so this is a type of the supercritical flow. Okay, so this is about the ethical consideration. For the first is public safety in hydraulic structure carry high energy flow. Potential danger is missed if the measures misdesign. So this is risk include flooding, collapse and erosion of the injury to the public. The ethical engineer ensure for the safe slope and flood velocity, durable material and proper reinforcement, winning net and maintenance access. Follow both of the this is also the follow board of engineer Malaysia BEM code of ethics, like the for the safety first lah, and rectangular inspection and also maintenance to prevent the failure. The public safety also is for the neighbors careful refills safety for the cost or speed and ethical goal. Their ethical goal is to protect life and uploading public trust issue. So the two is the sustainable in engineering practice. They are focused on long-term performance and minimal environmental damage. Use durable, low-maintenance material, example concrete, natural lining, and optimize slope and design to reduce energy loss and maintenance costs. Adapt design to climate change and future rainfall increase. Incorporate eco-friendly drainage or water use system. Combine technical efficiency with the environment care and ethical goal. Their ethical goal is designed for today needs without harming future generation. And the third is environment impact. This is all hydraulic design, which is like the pipe channel sluice gate hydraulic jump affect the ecosystem. So it is also have a high flow velocity or steep slope, more than erosion, sedimentation, and habitat loss. Engineers must minimize damage using minimize damage like using the riprap or concrete lining, energy dissipation or stealing benzene, vegetation and natural protection, and also must follow the Department of Environment DOE guidelines, conduct environment inspection assessment EIA before construction, and balance between engineering efficiency and ecological protection. And their ethical goal is preserve natural will while achieve function design. This is about the individual and teamwork reflections. So throughout this assignment, my team, Omar Faruqi and I collaborate to solve the main equation problem for the uniform flow in a cycle pipe. I was responsible for performing hydraulic calculation, including determining the area, hydraulic radius, and bed slope. Adam Omar Faruqi is assistant is creating diagram with verifying the result. We communicate effectively using online discussion and share document to ensure accuracy and clarity. Our teamwork demonstrated mutual respect, responsibility, and professional conduct. We also create each cross check each other work to minimize the calculate error. And through this process, I learned the importance of collaboration, time management, and valuing other input. These assignments not only enhance my understanding of the hydraulic principle, but also strengthens my ability to work efficiently in a one team, reflecting the true essence of professional ethics in civil engineering.